Okay, in the last video, we just did a couple of problems using the factor theorem. And so basically what that is that if we have a remainder of 0 after we complete the division, so in my second example, I have that right here, that then the quotient that we receive from that times the original divisor. In this case, it would be x minus 1. And then when I used the synthetic division, I had to solve that factor right there. And so what that's telling me is that if I plug in 1 into this equation, it will equal 0. So hence, this is one of my factors, and then the quotient was the other factor right here. And there's a pretty simple example I had up here with the definition. 20 divided by 4 is 5 with a remainder of 0. So hence, if you were to take the divisor and multiply it by the quotient, that is equivalent to the original value that was being divided. And so that's what I'm pointing out right here, is that this is equivalent to the original polynomial up here. So using all that, we're ready to what we're going to do is we're going to rewrite this polynomial right here in fully factored form. And what that means is we want to factor as much as possible, and ideally we don't want to have any exponents higher than 1. We don't have anything more than just x's. And so what they're going to do here is they're going to start off by giving us some information. So they tell me, you know what? X plus 3 is going to be one of the factors. So what that means is that this is going to split into an x plus 3 times, I got to figure that out. And so what we're going to do is use synthetic division. So I take that factor, the given factor, and to use synthetic division, I have to set it equal to 0 and solve. And so then that gives me that number to help me complete the synthetic division process. So here we go. I'm going to make my half rectangle, and then I'm going to put those coefficients from the polynomial up here. So let's see, 5, 9, negative 26, and a negative 24. And so I should get a remainder of 0 when I use negative 3 as that number. So we start our process. We should hopefully be pretty good at this now. So you drop the first one, then you're going to multiply, put it in the next column. Add those together. That gives us negative 6. Multiply, put it in the next column. That's going to be a positive 18. Then we add those together. Let's see, that's going to give us negative 8. Then a negative 8 times a negative 3 gives me positive 24, remainder of 0. Bingo. So now I found that missing piece that should go right here. So actually, I'll go ahead and fill it in. So you're going to reduce everything by a power of 1. So instead of being 5x cubed, this is going to be 5x squared, then minus 6x, and then minus 8. And so that's equivalent to what I have up here. Now, I'm not done yet because it does say in fully factored form. So I want to see if I can break this one down now. So there are a couple different ways you could factor this. If you want to do guess and check, that's fine. The way I taught y'all in the past, in some past videos, is I kind of like to do this process here. I'll go ahead and review it over here. So let's see, if I have 5x squared minus 6x minus 8, what I do is I multiply the edges together. So the leading coefficient and the constant, which is negative 40. And then I'm trying to find two numbers that will multiply to give me that negative 40, but add to negative 6 in the middle so that I can replace that right there. And so let's see. I'm thinking maybe 4 and 10. So it's probably going to be a negative 10 times 4. And then those two numbers will add to negative 6 right there. So we keep the 5x squared. That stays the same. We're replacing that minus 6x with a minus 10x and a plus 4x. That's the same thing as a minus 6x. And then we still have the minus 8 right there. So what that does for me is it allows me to do the factor by grouping process. And so what we do is we group the first two, we group the second two. So looking at the first two, what do they have in common? Well, they're both divisible by 5 and x. So we'll go ahead and do that, and that will leave me with x minus 2. Now, whatever I factor out of the second one, I need to have my leftovers match. It needs to be an x minus 2 also. So it looks like I can pull out a 4, and that should do it for me. I'm left with x minus 2. And then from here, what we're going to do is factor out the x minus 2 from here, because between this addition in the middle, that's what they have in common. So we're going to factor this out now. So we're going to factor out the x minus 2, and then my other factor is the 5x plus 4 that's left behind. So those are my leftovers this time. And so this right here is equivalent to that. Okay, so that's what I'm going to want to do. I'm going to want to write my final answer. And the order that you write the factors doesn't really matter what order you put them in. But let's see, I'll put my x plus 3 first, and then I'll put my x minus 2, and then we've got my 5x plus 4. So if you switch around the order of these three, it doesn't really matter because multiplication is commutative, so it doesn't matter what order they get multiplied together. And so this right here, just to be clear, is equivalent to the original function. So maybe I should put f of x right here. So f of x is equal to that right there, all my factors. Okay, so that's kind of part of the usefulness of synthetic division, is it kind of helped us factor this, while otherwise we would not have been able to factor it. So you could try factor by grouping from the beginning, but that would not have worked in this particular example. So we're going to kind of continue doing this, but we're going to go a step further on these next couple of examples, and we're actually going to go ahead and factor it and then actually solve it, actually find all the x-intercepts, find the solutions that make the function equal 0. So let's go ahead and look at our second one. So right here it says, when the polynomial f of x is equal to 4x cubed minus 7x squared minus 5x plus 6 is graphed on a standard coordinate plane, 1, 0 can be seen at x equals 2. So that's, by 0, that's code for x-intercept, right? And so so x-intercepts y equals 0, right? Hence f of x would equal 0. So this value will cause my function to equal 0 if I plug that in for x. So use the fact that 1, 0 is known to factor f of x completely by using synthetic division. Then we're going to go one step further, and we're actually going to find all those zeros. All right, so let's just jump in. So what's different here is the one up above, they actually gave me the factor. Here they went ahead and solved for it and just said x equals 2. So just FYI, what we're trying to do is factor this. This, as a factor, if you were to go backwards, would be x minus 2. So that's going to be one of the factors right there, x minus 2. So just keep in mind that those two things are equivalent right there. X equals 2 and then x minus 2, because if I plug in 2, 2 minus 2 is 0. So that would cause the polynomial to go to 0. So let's go ahead and do our process. So let's see, 4, -7, -5, and a 6. And the number we're going to use is 2. So use 2, don't change its sign. It's already been solved. So we'll go ahead and drop the first one. Multiply, put it in the next column, add together. Multiply, put it in the next column, add together. And so on. And so -3 times 2 is -6. And I get that remainder of 0 that I wanted. So now what we've done is we've taken this and we've factored it into x minus 2. And then the other factor is made up of my quotient, which is going to be 4x squared plus x, and then minus 3. So far, that's what this, I'll go ahead and put the function notation. That's what this function, we've basically factored it a little bit. And so we want to factor it, though, completely. So we're going to have to do the same thing we did up above with this. And so once again, I'm just going to follow that method I showed y'all before. So let's see, I've got 4x squared plus x minus 3. And so the way this works is I'm going to multiply the leading coefficient and constant, which is -12. So I'm looking for two numbers that multiply to give me -12, but will add up to 1 in the middle right here. And so think about it for a moment. And let's see, I believe it should be a +4 and a -3. They multiply to give me -12. those two numbers would add together to give me positive 1 in the middle. So that's what we're going to do. So we still have the 4x squared, but then we're going to replace this, and it doesn't matter which one goes first. I'll put the plus 4x and then minus 3x. I could switch the order if I want. It will not make a difference. And then we'll have the minus 3 right there. So what I have written in red is equivalent to what I have above. I'm just kind of manipulating this. And so then we do our factor by grouping. And so this one, a little tricky. So on the first one, I can pull out a 4x. That's not difficult. And that leaves me with x plus 1. Well, what you'll notice is I have two negatives. So I not only want to pull out a 3, I need to pull out a minus 3. And that will turn my leftovers into positive x plus 1. And if you want to, you could redistribute to see that, yes, this is equivalent to what I have written down below. But we want to go ahead and finish our process though. So I'm going to take this and factor out the x plus 1 from here. So this is going to get pulled out here. So we're going to pull out the x plus 1. And then my other factor is going to be the 4x minus 3. Okay, so that is what I have written in purple here, what we're going to write there. So on your homework, you're going to have a spot for, give the function, the polynomial factored completely. So you're going to have your x minus 2. That's actually the given one right there. The x equals 2. That's written in factor form as x minus 2. And then the quotient part got factored into x plus 1 and 4x minus 3. And at this point, this should be pretty familiar. We've done this quite a bit in other sections where we take each factor, set it equal to 0, and solve. And so I'm kind of running out of room, so I'm going to do some of this in my head. And it doesn't matter what order you put these in. So the first one, you set this equal to 0 and solve, you're going to get a 2. And once again, that was the given one right there. Then take x plus 1, set that equal to 0 and solve, you're going to get negative 1. And then the third one, set this equal to 0. I guess I'll show you this one just because it's a two-stepper. So let's see, we're going to have to add 3, and then we're going to divide by 4. And so we get 3/4. So 3 over 4 is my third solution. So that's how it's going to look on your homework. They're going to have a part for you to put the factored form and then put the set of solutions. Once again, the order does not matter. Okay, so I have one more, and it's pretty similar to what we have been doing. Okay, so sometimes we just use a little different vocabulary. So this time it says find all the roots slash zeros. Those basically, they're interchangeable. Basically, it means our x-intercepts. Okay, so find all the x-intercepts of this polynomial given that f of -5 equals 0. So what's interesting is each time they gave us a different notation for the solution. So on the first one up here, they gave it to us as a factor. Oops. The first one up here, they gave it to us as a factor. Then the second one, they just said, hey, you'll see an x-intercept at x equals 2. And it's kind of similar to what they gave us here. They say, hey, f of -5 will equal 0. Essentially what they're saying is when x is -5, y is 0. So once again, they're giving you an x-intercept. So in factored form, this would actually be written as x plus 5, because when you plug in -5, it will cause the factor to equal 0. So just keep that in mind right there. But we're going to go ahead and do our synthetic division. So we can break this down a little bit more. So let's see, I'm going to have a 2, a 5, a -28, and a -15. And so I'm going to take the -5. So I do want to use -5. Don't change the sign of that. And so we'll go ahead and drop the first number and start our process. So 2 times -5 is -10. Add that together, -5. -5 times -5 is 25. Add that together, I get -3. -3 times -5 is 15. Add that together, I get 0. Okay, so what we've done so far, I'm going to take this and rewrite this as a polynomial. So 2x squared minus 5x minus 3. So what I've done is I've actually essentially factored this into two pieces. So let me go ahead and write that down. So we're going to have f of x equals, and so this written as a factor is this right here. That's my divisor. That's what I basically divided the function by, x plus 5. And the quotient that we got was 2x squared minus 5x minus 3. Okay, so in order to find all the solutions, I need to go ahead and factor this part just like I did the previous two. So let me get a little bit more room. And what I'll do is I'll probably use this one right here. So let's see. I'm going to go ahead and erase that. Okay, so what we're going to do is do 2 times negative 3, which is a negative 6. And then we've got to figure out what to split that into where it would add up to negative 5, these two numbers. And it should be a negative 6 times positive 1. That's negative 6, and it adds up to negative 5. So that's what we're going to replace this with right here. So we still have our 2x squared. Then we're going to put a minus 6x plus 1x or plus x, and then you have a minus 3 right there. And then from here, we'll do our grouping process. So on the first one, I'm going to pull out a 2x, and that's going to leave us with x minus 3. And well, that's kind of weird. I already have x minus 3. I have the leftovers I want. What I need to do is basically kind of put a symbolic 1 here, factor out a 1. That won't change anything, but it will kind of help me with my next step. And so then the next step is we factor out that common leftover, the x minus 3. So we factor out x minus 3, and then the other factor will be made up of 2x plus 1. Okay, so that is what's going to replace what I have underlined in green over here. So the fully factored form would be f of x equals x plus 5 times x minus 3, oops, and then times 2x plus 1. So that's, we basically just factored the polynomial there, and then we'll take each one of those, set them equal to 0, and solve. So when you set that equal to 0 and solve, you'll get negative 5, which was the given one. Set this equal to 0 and solve, you'll get 3. And then this one, you'll get negative 1/2. If you were to take this, set it equal to 0, and solve. Okay, so hopefully you've got your, hopefully the actual synthetic division process is basically an afterthought now. That should be fairly simple. We've kind of moved on to now the application of using it. And so the next section is going to kind of be more of the same. The only difference is we're not going to give you any hints. So what will happen is you'll just start out with the polynomial and we'll say, hey, go ahead, find all those solutions for us. We're not going to be giving you any hints. And so there's a process for it, and that's what we'll cover in the next section. And so if you have any questions or concerns, let me know before you move on to the next one, because you want to make sure you have a fully grasp what we've been doing here.